Welcome to episode 66 of 100 Days of Data. I'm Jonas, an AI professor here to explore the foundations of data in AI with you.
And I'm Amy, an AI consultant, excited to bring these concepts to life with stories and practical insights. Glad you're joining us.
Google's machine learning powerhouse, TensorFlow, has become one of the most popular tools in AI development worldwide.
Yeah, when you think ML tool, TensorFlow often comes to mind, powering everything from speech recognition in your phone to complex healthcare diagnostics. It's everywhere.
Let's start by understanding what TensorFlow really is. At its core, TensorFlow is an open-source software library developed by Google Brain for numerical computation using data flow graphs.
Okay, pause. Data flow graphs sound a little abstract. How do you explain that in everyday terms?
Imagine you have a big factory assembly line where each station performs a specific operation on an object passing down the line. A data flow graph is like that assembly line for data. Nodes represent operations, and edges carry data called tensors between them.
So, tensors are just data. What makes them special?
Great question. Tensors are multi-dimensional arrays. Think of them like generalizations of numbers, vectors, and matrices. They hold data in various shapes and sizes, making them perfect for the kind of math AI models need.
Got it. So TensorFlow lets you build a kind of assembly line for tensors to flow through operations that train AI models.
Exactly. This framework design was a leap beyond earlier tools because it allowed computational graphs to be defined statically or dynamically. Initially, TensorFlow used static graphs, meaning you define the entire computation before you run it.
And why does that matter? In the projects I work on, flexibility is a big deal.
Static graphs have advantages like optimizations and portability. You can compile the graph once and run it efficiently many times. But the downside is less flexibility when you want your model to adapt on the fly.
I remember that being a hurdle in some early TensorFlow projects. It felt rigid compared to later tools.
Which brings us to eager execution, introduced later. It lets TensorFlow evaluate operations immediately rather than building a graph first. That approach feels more like regular programming, much easier to debug and iterate.
That makes a huge difference in practical settings. For example, in the automotive industry, when developing AI for autonomous vehicles, teams need to prototype quickly. TensorFlow's eager execution helps them experiment faster.
This evolution keeps TensorFlow relevant even as competitors emerged.
Speaking of competitors, frameworks like PyTorch came along with eager execution from the start, winning fans for their user-friendly design. But TensorFlow fought back with its own updates.
Absolutely. TensorFlow 2.0 unified the static and eager worlds, giving developers the best of both approaches.
And it wasn't just about the API. TensorFlow also offers a huge ecosystem. TensorFlow Extended for production pipelines, TensorFlow Lite for mobile and embedded devices, and TensorFlow.js for running models in the browser.
That breadth is impressive. It means organizations can use the same framework from research to production to deployment across devices.
A real-world example I've seen is in healthcare. A hospital group used TensorFlow to develop an AI model that analyzes medical images for early tumor detection. They started with experimental notebooks, then moved to TensorFlow Extended to build a full pipeline that integrates with their electronic health record system.
That's a perfect illustration of TensorFlow's strength in scaling, from prototype to enterprise-level application.
Exactly. Though I always emphasize that you don't have to be a data scientist to leverage TensorFlow-powered solutions. Many companies use pre-trained models and TensorFlow Hub to customize AI with less coding.
Right. TensorFlow Hub offers reusable model components, which accelerates development and democratizes AI.
On the flip side, the sheer size and complexity of TensorFlow can be intimidating for newcomers. The learning curve is steeper than some newer frameworks.
That's true. TensorFlow's extensive API can feel overwhelming, but its maturity means robust documentation, community support, and integrations with platforms like Google Cloud AI services.
And that ecosystem support translates directly into business value. Faster iteration cycles, easier scaling, and a reliable platform mean companies can deploy AI solutions with lower risk.
Let's talk briefly about the deep learning aspect. TensorFlow shines particularly in deep learning, neural networks with many layers.
Deep learning is the magic behind most modern AI breakthroughs, like image recognition or natural language processing.
TensorFlow provides the tools to define layers, activation functions, optimizers, and loss functions elegantly. It abstracts the complex math while still allowing fine control.
In retail, for instance, TensorFlow-powered deep learning models help recommend products by analyzing user behavior. This drives personalized marketing, increasing sales and customer engagement.
To summarize the theory, TensorFlow is a highly versatile open-source software framework designed to facilitate creating machine learning models, particularly deep learning models, by representing computations as data flow graphs with tensors.
And on the practical side, it's used everywhere, from self-driving cars to medical diagnostics to retail recommendations, thanks to its flexibility, scalability, and comprehensive ecosystem.
Before we wrap up, it's important to remember that TensorFlow is continually evolving. Google and the community constantly update it to improve usability and performance.
Staying updated on these improvements can give businesses a competitive edge, helping them build smarter models faster.
Let's hit the key takeaways. TensorFlow revolutionized AI development by providing a flexible yet powerful framework centered on tensors and data flow graphs, enabling researchers and businesses to build scalable ML models.
And from my side, if you're looking to bring AI into your business, TensorFlow's ecosystem offers real tools from prototyping to production that make complex AI accessible and practical.
Next time, we'll dive into PyTorch, another leading AI tool that's popular for its dynamic nature and ease of use.
If you're enjoying this, please like or rate us 5 stars in your podcast app. We'd love to hear your questions or comments, which might appear in future episodes. Until tomorrow, stay curious, stay data-driven.